Alright, here's a little video on how to do 6.6 and number 2 in the homework. This is the question that I had that should be similar to yours, and it says if n times p is greater than or equal to 5 and n times q is greater than or equal to 5, estimate p, the probability, estimate the probability that we have fewer than 5 when n is equal to 13 and p is equal to 0.4, using the normal distribution as an approximation to the binomial. So then it also continues, if n times p is less than 5 or n times q is less than 5, then state the normal distribution is not suitable. And so that's why they have two options. Option A, where you can answer the question, option B, where you say you can't even use the normal distribution. And so we absolutely need n times p and n times q to be greater than 5. And we have that in this case. If you look at the n that they gave us n was 13. They gave us p was equal to 0.4. So hopefully you remember that q is 1 minus p, or in this case 1 minus 0.4, which is 0.6. So if we look at n times p is 13 times 0.4, and 13 times 0.4 is equal to 5.2, which is greater than 5, so it's checking out there. N times q is equal to 13 times 0.6. Probably don't need to try this, it's going to be higher, but just to illustrate, this was 7.8, and that's bigger than 5, so we're good to go. We can use the normal distribution as an approximation to the binomial. So if we're going to use the normal distribution, then we need two things. We need a mean, and we need a standard deviation. The mean is n times p, as you know, and the standard deviation is the square root of n times p times q. We saw this before in chapter 5, and they're bringing it up here again. So if we go to calculate the mean and take n times p, well, we already have that. That was a 13 times 0.4, which is 5.2. So the mean is 5.2. Make that more visible. The standard deviation is the square root of 13 times 0.4 times 0.6. Running that in our calculator, we get something that goes on forever. I decided to round it to the hundredths and do 1.77. So what we have is a question, and the question is, find the probability of fewer than 5. So 5's our critical number, but we can't use 5. So whenever we're in a situation where we're using the normal distribution to approximate something that's wasn't normal to begin with, it was binomial. In this case, if it's binomial, it's all partitioned up, right? It's not continuous, but yet we're using a continuous function. And so we would love to come in here and put a 5, but we can't. Our choices are 4.5 or even 5.5, which would be on the other side. So let me come in here and make this a little bit bigger. We have to decide whether we're doing 4.5 or 5.5. And that's always a choice. So you'll never ever use the number that they give you. So the question is, should I be using 4.5 or 5.5? Well, if it's fewer than 5, we want to go to the left. So picture a shading area to the left. So here's my two choices, 4.5 or 5.5. Now you want to have fewer than 5. So if I shade this, every number in here, everything 4.5 or below is fewer than 5. If I shade this, now why am I going to the left? Because it says fewer than. If I shade this one right here that has the 5.5, 5's included, and that's a problem because 5's not included in fewer than 5. So 4.5 is our guy. And we're grabbing something like this. So we have to make that decision for the continuity correction, and it's all dependent upon the question and the shading that goes on. So that's why we recommend drawing a picture. So I'm going to do this the book way, right? If you're using StatCrunch, you can use StatCrunch and get that done. But the book way would have us reflect back that, oh, I need to use a chart. So z equals 4.5. I got to find the z-score for 4.5 minus 5.2 divided by 1.77. Rounding that to 2 decimal places makes this become a 0.40. Negative. Sorry, I didn't say the negative. Negative 0.40. If we look that up, we're going to be done. So let's go look that up together. I think I have the charts right here. Get out of math, 335. Here's the z chart. And we're looking at, remember, negative 0.4. Well, that's right here, 3346. So negative 0.40 is 0.3346. And let me just take that off of there, just in case it doesn't save that way. So 3346, and what are we going to do? I'm going to come over here and write 0.3346. Now 3346 is the area to the left. That's what we want. So the probability that we're fewer than 5 is equal to 0.3346. And I checked that out, and it did accept that as the right answer. I believe that with StatCrunch you'll get something that may be slightly different, but it's accepting both answers. So don't panic about that. It is respecting the way that the book addresses it, and that is giving it from getting the numbers from a chart. Hope this helps.